Hey 7th grade, welcome back to my channel, welcome back to my floor. This is still my setup, but I think I figured out the light better. So today's lecture is going to be pretty short. It's about the periodic table. You've seen it before. A lot of this is a review of what you learned last year and the year before in 5th and 6th grade. But it's stuff you need to remember in case it ever comes up on a standardized test. So go ahead and get the slides up. No warm up this time, yay. So, the periodic table. First question on the second slide is, what is it? And it's a very good question. It's a tool that shows all known elements. All the known elements organized numbers 1 through 118. There are, lots of them are naturally occurring, meaning they're just in our environment somehow. But there's a good portion of them that are considered synthetic or they're man-made. They usually have been either synthesized in a laboratory or something that was left over after an event like a nuclear explosion. So they haven't been found naturally, but it was left behind after something. And as we know, an element is a pure substance. It can't be broken down into any further materials. So they found this new element because they couldn't break it down. So the table is organized 3 ways. Number 1 is by the atomic number. That's the 1 through 118. And that atomic number is equal to the amount of protons in the nucleus of an atom. So the higher you get, the more protons are in their nucleus. The next way is electron configuration. And this isn't the number of electrons, this is how the electrons are in the atomic model of the atom. Remember from last year that electrons exist in shells or kind of like orbits, how our planets orbit the sun. So it's how they are placed throughout all those levels, and their valence is very important. That is their last layer of electrons, their outermost layer, which leads into the third way it's organized, chemical properties. Remember from last year, chemical properties like whether it's a good conductor or if it's malleable or ductile or whatever, all depends on the valence electrons and their placement. So electrons are really important along with protons and neutrons, and it tells you how the table is organized. So if you know something has 92 electrons, you got to go look for number 92 because that's equal to the amount of protons. So if you look at the first picture of the periodic table, I found a simpler one to look at. That is showing you all the elements. You'll see that they're all different pretty colors. That's you know, whether they're a metal or a non-metal, all that kind of stuff. It might be hard to read some of it, so that's why they bump out the one little tile for you of hydrogen. So if you look at the yellow tile for hydrogen, that's H. Its atomic number is 1. Its symbol is H, as I said. And below that you'll see the full name, and then you'll see the atomic mass. Now this has the true masses on the table. They're really funky numbers because it's the sum of the neutrons and protons and all that in the atom, so it's kind of a weird number because we all know they're very small and very light particles and they're hard to measure. But whenever in this class, whenever we look at that, I'll have them simplified. They'll be rounded to the nearest whole number. So in this example, if we were to look at the hydrogen and not look at the funky number, it would be atomic number 1, mass 1. Okay? If I ever want you to work with an element, I'll give you a simplified table. So if you look at all those, see if you can spot atomic number 4. That's beryllium, Be. So you can see that all of them are in columns and rows. The rows are called periods, and the columns are called groups. Some people also refer to them as families, but that can be a bit confusing. I usually refer to it as group. So We'll start with the periods. Those are all the rows. It's 1 through 7, so hydrogen is row 1. So is helium. So you have to look at it as a full table. If you want to print one out and draw lines, go for it. So hydrogen starts row 1, lithium's row 2, sodium's row 3, potassium's row 4, and so on. You'll see at the bottom there are 2 rows on this one. They're blue and green that are bumped out. So they are technically part of rows 6 and 7. Not technically, they are. But we don't put them in there because then the table will be really, really long and it would be hard to look at. So they're just bumped out. They're called the lanthanide and actinide series, named solely because those are the first elements in each row. So they are periods 6 and 7. So don't forget, they're not periods 8 or 9, they're periods 6 or 7. So if you look at the columns, those are all the groups, and they are 1 to 18, starting from left to right. So hydrogen is 1, beryllium is 2, scandium is 3, all the way over to zinc. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Zinc's in 12. Boron is 14, carbon is 15, and so on, all the way over to helium at 18. So they all go in order from left to right and in order from top to bottom. Pretty simple. If you switch to the next slide, you'll see the more complicated version. You might have to make it full screen to see it. I pulled that image right off Wikipedia, so if you want to go to the periodic table Wikipedia page and just scroll down, it's all there. It gives you the more detailed look at all the atomic masses and weights. So really quickly, let's talk about all these protons and electrons and neutrons. I call it PEN because I like to do that and I'm lazy. So whenever I ask you to do the PEN of it, I want you to find protons, electrons, and neutrons. So atomic number is equal to the amount of protons, as I said, which is also equal to the amount of electrons. So if an element's atomic number is 36, it's going to have 36 protons and 36 electrons. You find the amount of neutrons by taking the atomic mass and then subtracting out the atomic number from that. So in the case of hydrogen, we took our mass of 1 and subtracted our atomic number of 1 to get 0. All right, so if you flip to the next slide, you will see that I did an example for you for helium. Helium's pretty easy. Its atomic mass is 4, its atomic number is 2, the symbol is He, and its name is helium, but you probably knew that. So to find the protons, we look at the atomic number, that's the red, it's 2. To find electrons, look at the red, it's 2. And now neutrons, I think you can do this math in your head. You take the atomic mass minus the atomic number. So 4 minus 2 equals, I hope you know the answer, 2. Okay, so we're going to do one more example by yourself. I did put the answers in the notes of the slides if you need it, but you can probably figure it out yourself. So take a second, pause the video if you need to. Let's look at mercury. Yeah, it doesn't start with M. Kind of weird. Hg. It's named after scientists found it. So, Hg is mercury. Its atomic mass is 201, and its atomic number is 80. So, let's start with protons. We know that's equal to atomic number. So 80. Electrons, equal to the atomic number, 80. Now lastly, we have to find our neutrons by subtracting our number from our mass. So 201 minus 80 equals 121. Did you get that? Good job, yay! So that was it. Your homework assignment is to pick any 3 elements that were not included in this presentation. So you can't do hydrogen, you can't do helium, you can't do mercury, whatever ones you want, I don't care. Go ahead and pick anything that weren't in the presentation. Tell me what it is, its symbol, its period, its group, and the protons, electrons, neutrons for all three, and just send it to me in email. All right, thanks, bye.